So now find the antiderivatives of these three functions. Well, with square root, you can rewrite that as x to the 1/2. Or I could rewrite it as x to the negative 1/2, and that way I don't have a fraction. This one in the middle is fine, x squared. But the thing is, this is the one case where you don't do that, because what we're going to be doing is the opposite of derivative would mean add 1, this becomes a 3, and then divide by that 3. Well, if we rewrote this one as x to the negative 1, then if you add 1 to the exponent and divide by that number, you would end up dividing by 0. So with this one, you just have to recognize that that came from the derivative of natural log. And it's a good idea, even if you recognize that right off, to just wait until you do all of the integrals and just do them all at once. Okay, so then now we're doing the antiderivative. So this symbol right here is going to disappear, saying we're done integrating. This, if you add 1, it's going to become a 1/2 positive, and then divide by that. So 3, and then it's to the 1/2 and divide by 1/2. Or if you want to save some time, you could invert and multiply, so multiply by a 2. Or we can do it in the next step. And then this one becomes, adding 1 becomes x to the 3 over 3, and this one becomes natural log of x. And then there is a constant of integration. So to check your answer, take the derivative of this, it will become that. Take the derivative of this, it will become that. Take the derivative of this, it will become that. And the derivative of a constant is 0. So we don't know what this constant is, but it's there. So this means you invert and multiply, so it's going to be a 6. In here, you can leave it as x to the 1/2, or you can put it back as the square root, whichever you prefer. And then the rest of it's already simplified. Just leave it as it is.